Hi, so just a quick video to demonstrate the Balmer VeriSense Smart Vision Sensor to be able to grade eggs by size. So I've fast forwarded through the whole setup of the camera, but you can see the egg here in view. So this takes into assumption that we're able to get a good trigger for each individual egg. Also that we can get the lighting conditions correct, whether we use external lighting or internal lighting or some specialized lighting, or to be able to highlight the egg as a good contrast difference between the background, or have the egg dark and the background bright, just so there's a good solid contrast difference between the egg and the background. In this scenario, I've had the egg as bright and the background as dark. So again, as you need for any kind of vision system, you want a good trigger to be able to get what you want in view. So would need a little bit of gapping between the eggs if that is possible, so they're not touching each other, and also that we could trigger off a leading edge of the egg. So of course, like I said, fast forwarded all the setup, so we've got the lighting and exposure correct, and we've got the sensitivity of the sensor correct to be able to see the edges of the egg. You can see if I reduce or increase the sensitivity, what we're able to see there. So we're going to have it at a decent level so we can see the egg there. Okay, so now we're going to checking of the features, and the feature we'll be using for this test is the area size tool. If I click OK, then what we have to do is select an area where the egg will appear, and in this case the tool is looking for dark areas versus bright areas, but in fact we want the complete opposite in this scenario, and we want the bright on the dark. And we then just adjust the binary filter so that we can see the highlighted area as the actual all the way to the edge of the egg. So we're counting all the pixels of the egg. You can see if I adjust the binary threshold too much, you see that I see the whole area. But if I adjust it to a level like so, only the area of the egg is highlighted. And the value here is giving us the number of pixels that it sees as part of that egg area. So of course, the eggs can be presented in any way, whether it's left edge leading, right edge leading, upside down, top leading, bottom leading, whichever it may be, as long as the egg fits within the area that we set up for the camera, then we're able to measure the total number of pixels that the egg is giving us. Now here we can set a threshold as to which we say it meets the size criteria. So with the egg area giving us here 165, nearly 166,000 pixels, we can say maybe for large eggs it can be, for example, anything between 150,000 to say 185,000 pixels. And you can see now that this is a large egg that I've selected here for this test, gives us a good result. And we can then set up multiple tools if we wish to use the digital outputs to do the sorting for us, and say, right, just do a copy of that tool, area size tool, and again just select the area that the egg will appear in. And in this case we may say, right, everything up to 135,000 is the limit for a medium-sized egg, and the minimum value is, let's say, 100,000. And again, we want to flip it from bright to dark. And you can see that for a medium-sized egg, there's too many pixels there, but for a medium-sized egg, which would have less pixels, there would be enough for it. and we would get the right output. So again, we just want to match the binary threshold that we had, and there we go. Right, so that's that tool set up. So we can then label these tools as what we want. So this one is large, large egg, and let's say this one is medium, medium egg. And so you can see, as I've selected a large egg, the large egg comes up, and because and it says it's an OK result, it's too big for a medium-sized egg, and so it's no good on this result. Okay, so now we can configure the outputs, or if you're using a different method rather than the digital outputs to give you the feedback of what size egg it is, you can output the string information of the size of the eggs in number of pixels here, and your PLC can then interpret this string of data. So you may have identifiers and separators and start digits that your PLC will understand. You can take this string bit of information and then have the PLC do the selecting and sorting for you, and the vision sensor just giving you the output on the number of pixels. And so within the PLC you can set up different criteria to say, right, anything over 160,000 means it's a large egg, anything under this 150,000 say is a medium egg, and that sort of thing you can do via the PLC. If you wish to use, you can set up partial results. So if I wanted output 1 to turn on or give me an OK result when it's only the large egg that it's seen, we can say, right, let's delete all this. Let's delete this feature. So when only the large egg gives us an OK result from the tool, then output OK on there. And for the second output, maybe we go to partial result 1, and we want to tell us when the medium egg is OK, then give us an output down this separate wire. So you've got the possibility to do that for 5 different outputs, and you can use those digital outputs via these separate wires to give you an output for large egg, medium egg, small egg, extra large egg, whatever you do from the number of tools that you've put in here. Or you can, via the output interface, output the number of pixels that you see here into the PLC, and then the PLC does the sorting for you. So let's just run you through some of the different scenarios and the number of different eggs that I tested. I think I tested 14 different eggs, and if I run that simulation for you now, you can see the different eggs that runs through, and also the size that it gives us here in terms of number of pixels. And these are all classified as large, and you can see here they all output as large there. Okay, hopefully that makes sense.